Okay, today we're going to talk about basic differentiation rules and rates of change, and we're going to do that without having to use much of the definition of a derivative, which was very involved and had a lot of busy work. I'm going to show you ways you can get around that and get the derivative without having to do all those calculations. Okay, so first, we're going to look at the constant rule. It says the derivative of a constant function is 0. That is, if c is a real number, then the derivative of c is 0. Okay, we will go ahead and go through the proof of this. So we're going to get out our formula that said that the derivative was equal to the limit as delta x went to 0 of f of x plus delta x minus f of c all over x minus c, which ends up being just delta x. Okay, so in this case, f of x is just f of c because it's a constant. So we can go ahead and change this to the limit as delta x goes to 0 of f of c plus delta x minus f of c all over delta x. Now, as delta x goes to 0, this just becomes f of c minus f of c over delta x. And then f of c minus f of c is, of course, 0 over delta x, which this is always a number, and I'm taking 0 divided by a number, that's 0. Okay? So this is equivalent to saying that the slope of a horizontal line is 0. Okay, so if you think about it, f of x equals c, that's any horizontal line. Okay, and the derivative is the slope, or the rate of change, and the slope is obviously 0. Okay? So here, if y is 7, what's the derivative? Well, y prime is 0. If f of x is 0, f prime of x is 0. If s of t is negative 3, then s prime of t is 0. And if y equals k times pi squared, where k is a constant, then this is just another constant. And so we would say that y prime is 0. So very simple. Okay, expanding a polynomial. So normally we did this in pre-calculus. I mean, you've done this in Algebra 2 as well. We use the Binomial Theorem. Unfortunately, due last year, we didn't get to that. But you can actually multiply this out just by foiling it if you wanted to. So this would be x plus delta x times x plus delta x. So that would be, if I FOIL that, first would be x squared. Outside would be x delta x. Inside would be x delta x. So that's plus 2x delta x. And then last would be delta x times delta x, which is delta x squared. If I want to cube that, I can take this and I could multiply it by x plus delta x if I wanted to. Or I could use the binomial theorem. I'm going to get x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Now, just a quick refresher, if you're going to use the binomial theorem to do this quickly, we use Pascal's triangle, which look like this: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So remember, you got that by adding these two to get this one, adding those two to get this one, adding those two to get this one, and so forth. So if I wanted the fourth, these are the coefficients that go on the front. And then my first term starts out at whatever power is here and goes down to 0. And my last term starts out at 0 and goes up to that power at the end. So this would be 1 times x to the fourth power plus 4 times x to the third power delta x to the first power plus 6x squared delta x squared plus 4x delta x cubed plus 1 times delta x to the fourth power. Okay. The power rule. Okay, this is super important. You're going to use this all the time. If n is a rational number, then the function f of x equals x to the n is differentiable, and the derivative of x to the n is n times x to the n minus 1 power. For f to be differentiable at x equals 0, n must be a number such that x to the n minus 1 is defined on an interval containing 0. Okay, what does this mean? It's very simple to do in practice. If I have a function like x to the fourth power, and I want the derivative, f prime of x, I'm taking this times this, so it's 4 times 1 is 4, x, drop the power 1. So if I had another function, we'll call it g of x, and it was, say, something like 5x to the third plus 2x squared minus x plus 6. Okay, g prime of x, using the power rule, 3 times 5 is 15, x, drop the power 1, plus 2 times 2 is 4, x, drop the power 1, minus 1 times 1 is 1, x to the 0, which is just 1, and then the derivative of that is 0, so there's my derivative. Find the slope of the graph f of x equals x to the fourth for each value of x. So if I have to find the slope, the first thing that I'm going to do is find the derivative. That's going to be 4x to the third power. Now I simply substitute in the value of x where I want to find the derivative. So here, if I want the slope at -1, I find f prime of -1. That's going to be 4 times -1 to the third power, which is -4. There's my slope at -1. If I want the slope at x equals 0, I plug in 0 for x, so this would be f prime of 0. 0 cubed is 0 times 4 is 0. F prime of 1 would be 4 times 1 cubed, which would just be 4. Find an equation of the tangent line to the graph of f of x equals x squared when x is -2. So what I want to find is I want to find the slope of this line at -2, so it's going to be like right about here. I want to find the slope of that, approximately that line right there. Okay, so how am I going to do that? Well, I'm going to take the derivative of x squared. So the derivative of x squared is f prime of x is 2x. I'm going to go ahead and substitute -2 in there. This is an equation that tells me the slope of the line tangent. So I plug that in, I get 2 times -2, which is -4. That's the slope of that line right there at -2. Now, obviously, as I go this way, that line becomes flatter and flatter and flatter until it's 0. The tangent line is 0. And then it becomes positive after that and gets steeper and steeper and steeper. This is a lot quicker than having to do the definition and do all those limits. The constant multiple rule. If f is a differentiable function and c is a real number, then c times f is also differentiable, and the derivative of c times f of x is c times f prime of x. I'm not going to go ahead and go through the proof of this for you, though, today. So, right here, y prime would be 3 times 5 would be 15, x, drop the power 1. Okay, now this gets a little dicey when I have something like this. So I find it much easier, instead of doing this, to rewrite this as 2 times x to the -1 power. That's the same thing as this. So now I can use the power rule when I take the derivative, and I go -1 times 2 is -2, x, drop the power 1, -2, and then if I need to, I can rewrite it like that again. Either one of those two is acceptable. Okay, this one here, I find it a little easier if you rewrite it like this. That's the same thing. So 4/5 times 2 is 8/5 times t to the first power. Done. Okay, what about if I have a square root? You can still use the power rule. So what I would do is I would change this to 2x to the 1/2 power, because the 1/2 power is the square root. So 1/2 times 2 is 1x. Drop the power 1, that's -1/2. So you could write it as 1 over the square root of x if you wanted to. Again, either one of those is acceptable. If I'm doing this problem here, I'm going to go ahead and change this to 1/2 x to the -2/3 power. Okay, remember, this is the top of, this would be a fractional power. This is the numerator, that's the denominator. It's negative because it's in the denominator. So now I can figure out y prime. That's going to be -2/6, which is -1/3 x to the -5/3 power. So if you wanted to write it like this, you could do that. It would be 1 over 3 times the cube root of x to the 5th. Those are the same thing. Okay, this one might be a little easier if you look at it like this. Okay, the derivative of that, power is 1, 1 times -3/2 is -3/2, x to the 0, x to the 0 is just 1, so that's it, you're done. the constant rule and the power rule can be combined into one rule. Okay, which we were kind of just doing that in the last one. So again, here we have another one. So I would change this to 5 halves x to the negative 3. And now y prime is going to be negative 3 times 5 halves is negative 15 halves x to the negative 4 power. Now you got to be careful of these because look at the difference here. This everything is cubed and this just the x is cubed. So make sure you take care of your algebra to start with. I would rewrite this one. 2 cubed is 8, so this would be 5/8 x to the negative 3. And then y prime is now going to be negative 15/8 x to the negative 4 power. So using these two as an example, I'll give you a minute to do these two on your own. So go ahead and pause the video right here, and then we'll come back and I'll do these two and you can compare your answer. Okay, so here's what I would do with this one. I would change this to 7/3 x to the, that's a negative power on the top. So if I put it on the or on the bottom, so if I put it on the top, that's just x squared. Watch out for that one, that's tricky. Okay, and then y prime then is going to be 14/3 x to the first power. Done. Now this one, everything's in the denominator. So I would go ahead, I would deal with this negative power first. This is the same thing as 7 times 3x to the second power on the top. Okay, remember if you have a negative power in the denominator, you just move everything with the negative power to the top and make it a positive power. If it's negative power in the top, then you put it in the bottom. Okay, so then I would deal with this squared first. This would be 7 times 9x squared, and that's 63x squared. So when you find y prime, that's going to be 2 times 63 is 126 x to the first power. Done. Okay, the sum or difference rules, these are super simple. The sum or difference of two differentiable functions f and g is itself differentiable. Moreover, the derivative of f plus g or f minus g is the sum or difference of the derivatives of f and g. So the derivative of f of x plus g of x is f prime of x plus g of x, and the derivative of f of x minus g of x is f prime of x minus g of x. So for example here, you can think of these as three separate functions. F prime of x, the derivative is going to be 3x squared minus 4. Okay, 4 times 1 is 4. The x becomes x to the 0, which is 1. That goes away completely because of the constant rule. So there's my derivative. Personally, I always find it easier to rewrite things like this. Like that. So I would rewrite that and then take the derivative. I'm just less likely to make mistakes if I do that. So 4 times negative 1/2 would be negative 2x to the third. 3 times 3 is 9x squared minus 2. Okay, what do I do with this thing? We don't really have a rule for dealing with this yet, so what I would do is divide everything first. So I would change this. I can divide an x out of all this, so this would be 3x squared divided by x would just be 3x minus x divided by x is 1 plus 1 divided by x would be 1 over x, which I'm going to go ahead and rewrite as x to the negative 1. Now I can take the derivative. So y prime, the derivative of 3x is 3. The derivative of negative 1 is 0. The derivative of x to the negative 1 would be negative 1x to the negative 2. And then if you needed to, you could go ahead and rewrite it as that. Either one of these two is fine. Okay. These are also super important ones. So the derivative of sine is cosine, and the derivative of cosine is negative sine. You need to memorize those because you're going to use those so many times. You need to not even be able to have to think about it. You just want to be able to do it. So y is 2 sine x. So the derivative would be, the derivative of sine is cosine, so this would just be 2 cosine x. Done. Personally, I would rewrite this as 1/2 sine x. And then I would take the derivative. So that's just going to be 1/2 cosine x. Tell you what, pause your video here, figure these two out on your own, and then unpause the video and compare it against what I get here. Okay, so y prime. The derivative of x is just 1. The derivative of cosine is negative sine, so this becomes minus sine x. Done. I should have a y equals here. So then you can say that y prime, the derivative of cosine is negative sine minus pi over 3. The derivative of sine is cosine. Pretty simple. Rates of change. A common use of rate of change is to describe the motion of an object moving in a straight line. The function s that gives the position relative to the origin of an object as a function of time t is called a position function. Over a period of time called delta t, the object changes its position by the amount of delta s equals s of t plus delta minus f of t. Okay? Then, by the formula, this you should know from previous math classes, and if you've got physics or some kind of science, other kind of science, rate is distance over time. Okay, so your speed is your distance divided by the time that it takes you to go that distance. The velocity is the change in the distance divided by the change in the time, or delta s over delta t. So the velocity is the derivative of the position function. Finding the average velocity of a falling object. Okay, so a ball is dropped from a height of 100 feet. The ball's height s at the time t is the position function s equals negative 16t squared plus 100 on the Earth. This is only true on the Earth. Okay? So if I take an object and I just let go of it and drop it, it will follow this formula, and this will be the start height. So if I were to drop something from here, that'd be like 6 feet off the ground. This would be plus 6. The negative 16 is a constant that is related to the Earth's gravity. Okay, so S is measured in feet, t is measured in seconds. Find the average velocity over each of the following time intervals. Okay, so from 1 to 2 seconds, we want to find the average velocity. Okay, so what we're going to do is we're going to take the change in the position divided by the change in time here. Okay, so that's going to be pardon me. Just change an S over change a T. Oops. Change in S over change in T. Okay, so from 1 to 2 seconds, if I've dropped something here from 1 to 2 seconds, how far is that going to drop on average? Now, what's going to happen in reality is this thing is going to speed up the longer that it drops until it reaches something called terminal velocity. Okay, so but this is going to give us an average. So I'm going to find S of 2. So that's going to be negative 16 times 2 squared plus 100. So that's 4 times 16 is negative 64. That's going to be 36. S of 1 is going to be negative 16 times 1 squared plus 100. That's going to be 84. So the change in S is going to be 84 minus 36. The change in T is going to be 2 minus 1. So 84 minus 36 is going to be 48 divided by 1. That's going to be 48 feet per second. Now, it's actually going to be slower than that at 1 second. It's going to be faster than that at 2 seconds, but that's the average rate of change there. Okay, now I could do the same thing here from 1 to 1.5 seconds. I don't have to do the 1 again because it's already done, but I can do S of 1.5. So that's going to be negative 16 times 1.5 squared plus 100. I get out my handy dandy TI-84 plus C Silver Edition graphing calculator. 1.5 squared times negative 16 plus 100, 64. So my change in S this time, I'm going to borrow the 84 from this previous one. That's going to be 84 minus 64 over 1.5 minus 0.5. And actually, you know what? I did this backwards because this should be, this is S of 1 here. This should be S of 1 here. So S of 1 is going to be 1. Let's see. 1.5 is 64. So this is going to be 1.5 right here. That's going to be 1. So this is going to be 20 divided by negative 0.5, which is going to be negative 40 feet per second. Okay, and if I go back here, I did this one backwards as well. This should have been 1 minus 2. So this would be negative 48 feet per second. The reason that's negative is because it's falling. It's getting closer to the ground. Okay, so again, I have S of 1 already is 84, S of 1.1. So let's go ahead and calculate that. S of 1.1. Actually, you know what? Go ahead and pause the video right here. You calculate this one, and then come back and we will look at it together. Okay, so if I do this, this is 1.1 squared plus 100. So 1.1 squared times negative 16 plus 100. So this is 80.64. Okay, so I'm going to take 84 minus 80.64 over 1 minus 1.1. So 84 minus 80.64, that's 3.36, divided by negative 0.1, and I get negative 33.6 feet per second. Okay, so what does that mean? You can see that it's falling. This was 0.1 second. This is 0.5 seconds. This is 1 second. It's speeding up, but it's getting closer to the ground, so it's negative. Okay, using the derivative to find the velocity. So at time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water. Because the initial velocity of the diver is 16 feet per second, the position of the diver is S of t equals negative 16t squared plus 16t plus 32. Okay, notice this formula is different than the last one. The last one was a formula for when you drop something. Okay, this one, when you jump off a diving board, you have an initial velocity. That's taken care of in here. So this is your start height, here's your velocity, here's your coefficient for the Earth. So, when does the diver hit the water? What is the diver's velocity at impact? So, let's see here. The diver is going to hit the water when the height is 0. So this is going to be 0 right here. Okay, so I can figure that out just by taking negative 16t squared plus 16t plus 32 and setting that equal to 0 and calculating the time. So the first thing I would do to simplify this is all of these are divisible by 16. I would divide out, in fact, I would divide out a negative 16 and I would get t squared minus t minus 2 is 0. And you could factor this thing. So I put a t here and a t here. My factors of 2 are 2 and 1. I want to make negative 1 here, so I'm going to go negative 2 and plus 1. Now this tells me that t plus 1, I got two numbers that I'm multiplying together to get 0. That means one of them has to be 0. So t plus 1 is 0, which would mean t would be negative 1. Or t plus minus 2 is 0, which means that t would have to be 2. Now, this is time in seconds. We can't have a negative 1. That's an extraneous answer. So when does the diver hit the water? At 2 seconds. So that answers question A. Now, what is his velocity? Okay. So I need the derivative of his position function. So the position function S of t is negative 16t squared plus 16t plus 32. I take the derivative of that. S prime of t is going to be negative 32t plus 16. Now I'm going to go ahead and put 2 seconds in here because I want to know what his velocity is at 2 seconds. So S prime of 2 is negative 32 times 2 plus 16, which is negative 64 plus 16, which is negative 48 feet per second. Done. Okay, here's your assignment. I would do as many of those problems as you can. This is good practice. It's not overly difficult assignment. So good luck with that, and I will talk with you next time.